Alright, boys and girls, this is our typical tenant space electrical riser closet. There's a lot going on in here. Those are the risers up to the roof. We're on the 32nd floor. Those are for the elevators. This is a bus duct, 480 bus duct for the high rise. We have three separate ones, high, medium, and low rise. 480 to 208. 480 to 208. 480 to 208. A lot going on up here. A lot of switches. A lot of nice, neat pipe work. Some of it's butchered. Certain things you see. Seal tight. Piping everywhere. Anyway, I got a real peculiar problem with one of these switches. I'm going to show you with the meter. And we'll see what it's, we'll see if we can fix it. Okay, boys and girls, we got our ground there. I'm gonna try and do this so everybody can understand what I'm doing here. So I'm testing voltage. Okay, I am familiar with a bastard leg, where the middle leg doesn't equal the same voltage as the two outer legs. This would be 208 to ground, and that would be 277 to each other. I'm sorry, 277 to ground, 480 to each other. They used to do this on Richmond Terrace in Staten Island, and you would come up to a panel and you would open it up, and the middle leg was a completely different voltage, nothing matched up, but it was usually designated. So here's what I got here. We'll check the top of the fuses. 265. 265, still within the 5%. What's going on there? 265. Now we'll check the bottom of the fuses. 265. What? That don't make sense. So when this issue presents itself on the secondary side of the transformer, you're thinking they tapped off a bastard leg and they didn't really know what they were doing. Because when you get to a 208 panel, you're getting like 56 volts on every third leg. And it's not even making sense. So you got to trace the power back to the point of origin. And that's obviously this going upstairs. You can't, it's buried in the pipework up there. But yeah, so we're gonna knife this off. We're gonna put some gloves on. We're gonna change these fuses. We're gonna see what happens. We got some nice Bussmans. Okay, see what happens. Side note, at 175 amps at 480 volts, you're gonna want to close the door before you shut the switch. Put on a pair of gloves. The building is from 1970. I don't know how old these switches are. Some are newer than others. Like that's a different style up there, but it still bolts onto the same bus duct. So after you shut that off, before you start grabbing any fuses or CTs for that matter, test it. Use your leads and test it. Don't use a tick tester. So we changed our fuses, we put our CTs back. I'm not sure if I was clear. These are current transformers. The power passes through there. It creates a current around that and acts as a transformer. And that's how we sub-meter the tenants. We obviously have a main meter downstairs with something very similar, but this is how we sub-meter the tenants. So after I got the fuses in, we do a quick continuity check just to be sure, and then we could close the door, put our gloves back on, turn it on. Alright, boys and girls, we're all set up again. We got our ground in the rivet there. We'll go to the middle one because we know that one was the problem. And we're at 265. 265 on top. 265 on the yellow phase. And then on the left side, which is the brown. There you go. There you go. So sometimes you got to trace the power back to the source because you don't really know what the heck's going on. I had to use a circuit tracer to find this, but now it's fixed and we don't have low voltage on the secondary side. Alright, boys and girls. It's a quick and easy one. Early in the morning. It's early. Alright. Have fun with your projects. Hope this helped.